ladies and gentlemen. We are working from Mrs. Blue's kitchen on a lab today. This is Thor. He's joining us. We are doing the effective particle size on a rate of reaction. So this is normally an introductory activity we would do to the chapter that we're starting this week. So if you guys will find this on your Google Docs and you need to record the data on there that I'm going to be giving to you as we work. So for part one, we are going to look at the effective particle size on the rate of reaction. So we're going to have three different size particles: a whole piece, a piece broke up into, a piece of Alka-Seltzer broke up into 8 pieces, and a piece of Alka-Seltzer ground into a powder. And we're going to check and see how much time that this takes for this reaction to occur. So I have 3 beakers, and I have a stopwatch here, and we are going to time how long the reaction takes to stop bubbling. We're going to start with the whole piece, and as soon as I add it to the water, I'm going to start timing. Now, some things can affect the rate of reaction, like stirring, molecular motion, increasing that. So if I wanted this reaction to go faster, I could kind of stir it around, but that would be cheating, especially since I want to keep it consistent for all 3 trials. So something like that would be a constant that we hold for the experiment. All right, so the reaction is slowing down as far as the bubbling goes. And stop time, 1 minute and 15 seconds, or a total of 75 seconds. All right, the next one we're gonna look at as far as particle size goes is Alka-Seltzer broken up into 8 pieces. So starting this reaction now. All right, so reaction is just about done here at time 1 minute and 8 seconds, or 68 seconds. Now, the third trial we're going to do is the Alka-Seltzer ground up into a powder. So starting that one. As you can see, this reaction is occurring much, much faster. There's a lot more particles in contact with the solvent or the reactant of water, and with that, the reaction's already finished at 24.87 seconds. All right, ladies and gentlemen, now we're going to work on part 2 of the procedure. With this part, we're looking at reaction rate versus temperature. So we're going to see how temperature affects how fast a reaction occurs. The first trial I have here is room temperature water. I really just pulled this out of my sink, and the temperature there is reading at 27.5 degrees Celsius. So 27.5 degrees Celsius. We're using a whole tablet for each one of these trials here. So starting with the whole tablet. All right, reaction with the whole tablet at 27.5 degrees Celsius is just about done. Say right about there, 52.87 seconds is the room temperature bath. Next up, hot water bath. Okay, now we're gonna do the hot water bath. Hot water bath is at 82.0 degrees Celsius. So 82.0. As you can see, this reaction is much, much faster with the higher temperature. And it is done in 26.15 seconds. Okay, we're gonna do our third and final trial of part 2. This one is with an ice water bath. Temperature of the ice water bath right now is 9.1 degrees Celsius. So we're gonna add the tablet and start. Okay, we're coming up on time for the last one with the ice water bath. And the stuff floated to the top. It's just starting to really trickle away. I would say we are good. 2 minutes and 21 seconds, which is 141 seconds for the final trial. Some of the things that I want you guys to really think about and look at with this activity is the effect of temperature on reaction rate and the effect of particle size on reaction rate. Some of the things that you should be looking at is the ideas in your notes dealing with collision theory. The more particles collide, the faster a reaction is going to occur. So it's all about increasing the collisions of particles in order to get a reaction to occur.